All right, let's embark on a little journey together. We're going to explore the absolute basics of, well, everything. We're going to figure out the one thing that connects you, the air you're breathing right now, and even the screen you're looking at. Ready? Let's get into it.
So let's start with a puzzle. What on earth could a book, the air all around you, and, well, you possibly have in common? It sounds like a riddle, right? But the answer is actually pretty profound, and it's the key to understanding, literally, the fabric of our universe.
And this is where we meet our guide for today, Aryan. He asks his teacher, Miss Mira, a really simple but huge question. What is all this stuff around us actually made of? It's a question kids ask all the time, but it's also a question that has driven science for, forever. It's the absolute starting point.
And Miss Mira gives him this perfect, simple answer. She says, everything around us is made of matter, and matter is just anything that has mass and occupies space. That's it. Just two things. It has some weight to it, and it takes up room. That's the foundation for everything we can see and touch. So remember our riddle? A book, the air, and you? The answer is, you're all made of matter. It's that simple. You all have mass, or weight, and you all take up space, which is volume. It's the one thing that connects, well, pretty much everything.
Okay, but hold on. A rock is obviously not the same as a glass of water, right? And that's totally different from the air. So if it's all matter, what's the deal? Well, let's join Aryan as he heads into the lab to explore the three main forms or states that matter can be in.
First up, we've got solids, like a piece of chalk, or the chair you're sitting on. They have a shape that doesn't change and a volume that doesn't change. Why? Because the tiny little particles inside are packed together super tightly. They're basically holding hands and not letting go, which gives it that hard, rigid structure.
Then we have liquids. Think about pouring water into a glass. It has a set amount of space it takes up. That's its fixed volume. But it doesn't have its own shape, does it? Nope, it takes the shape of whatever you pour it into. That's because its particles have a bit more freedom. They can wiggle around and slide past each other. And last but not least, gas. Imagine blowing up a balloon. The air inside doesn't have a fixed shape or a fixed volume. It just spreads out to fill the entire balloon. That's because the particles in a gas are just going wild. They're super far apart and zipping around all over the place, filling up whatever space they can find. So here's a quick cheat sheet to see it all at once. Solid, fixed shape, fixed volume. Liquid takes the container's shape but has a fixed volume. Gas fills the whole container, so no fixed shape or volume. It really all just comes down to how much freedom those little particles inside have to move around.
Okay, so I keep talking about these particles. What's the story there? We can't see them, right? This is where we have to zoom in, way in, to the unseen world inside matter. Because understanding this is the secret to everything we've just talked about.
So here are the secrets of particles. Rule 1, everything, and I mean everything, is made of tiny particles. Rule 2, these particles are always moving. Even in a solid rock, they're constantly vibrating in place. Rule 3, they're attracted to each other, like tiny magnets. And here's the kicker. It's the tug of war between their movement and their attraction that decides if something's a solid, a liquid, or a gas. That's it. All right, so Aryan gets the whole solid, liquid, gas thing. But then he has another question. Can matter change? Can it go from one state to another? And the answer is yes, absolutely. But it leads us to two totally different kinds of changes, or transformations. Let's start with what we call a physical change. The classic example is melting ice. You've got a solid ice cube, you add some heat, and it turns into liquid water. But here's the really important part. It's still H2O. It's still water. Nothing new was made, it just changed its form. And you see this everywhere. Boiling water? That's just water turning into a gas called steam. Still water. Tearing up a piece of paper? Still paper, just smaller. The big idea with the physical change is that you don't create anything new. And a lot of the time, you can even reverse it, right? You can freeze that water right back into an ice cube.
But what about when you do something more dramatic? What if, instead of cutting that paper, you burn it? Now that feels different, doesn't it? Something fundamental has changed. You can't just put it back together again.
That, my friends, is a chemical change. When you burn paper, it's gone. What you have left is ash and smoke, totally new substances. It's like when iron rusts. That rust isn't iron anymore. It's a new thing called iron oxide. Or when you cook an egg, you can't go back. The main idea here is that a brand new substance is formed, and these changes are pretty much permanent.
So let's put it all together. A physical change? The stuff is still the same stuff, it just looks different. Think ice to water. A chemical change? You've created something brand new. Think paper to ash. Getting this difference is honestly a huge step in really understanding how the world works.
So now that Aryan and you understand all this about matter and change, the world starts to look different. It's like you've been given a pair of science goggles. You can suddenly see all these amazing processes happening that were just hiding in plain sight before.
And that's really the magic of it, isn't it? It's not just about memorizing facts. It completely changes how you see things. A puddle drying up on a hot day, a log crackling in a fire, those aren't just random events anymore. They're part of this huge, incredible, and totally understandable scientific story.
And that's really the big takeaway here. Just a few simple ideas about matter, particles, and change give you this powerful new way to see the world. It's a lens that shows you the hidden machinery behind, well, everything. It's the one story that ties it all together.
So I'm going to leave you with a challenge. As you go about the rest of your day, what invisible changes are you going to spot? When you see steam rising from your tea, will you think, hey, that's a physical change? Or when you see toast browning, will you know that's a chemical change happening right there? The story is unfolding all around you. You just have to know how to look.